All right, hello everyone, and welcome to the GitHub Virtual Meetup India edition, the third virtual meetup happening in India on November the 3rd. So welcome everyone to all of you joining across from various parts of India and even other regions. I'm Karan and I manage developer relations for GitHub in India. So before we get started, I want to tell you a little bit about what's new at GitHub. So let's get started. All right. So once again, welcome everyone. And a quick intro about me. I manage developer relations for GitHub in India. And I'm a developer by heart and really passionate about DevOps and open source. And when I'm not into DevRel, DevOps, or open source, you can find me learning more about acting, filmmaking, etc., and reading a lot of books. So you can connect with me on at MVKaran on Twitter, GitHub, LinkedIn, pretty much everywhere. All right, so I'm going to be talking a little bit about what's new at GitHub. But before that, let's take a look at the agenda. I'm really excited for today's meetup. We have a really power-packed agenda with some amazing speakers talking a lot about DevOps with GitHub. That's going to be the theme for today. We're going to have Sadagopan Rajaram, who from GitHub will be talking about DevOps at GitHub. And then we're going to have Petra from AWS talk about deploying to AWS ECS using GitHub Actions. We're going to have one project spotlight as well of Hasura GraphQL engine, where the co-founder of Hasura project, Rajoshi, will be joining us talking about their journey towards open source. And then we're going to have Dharmesh, who's a Google developer expert, talk about serverless deployment on Google Cloud Run using GitHub. And then finally, we're going to have Dixit, who's a customer engineer at Azure, talk about how you can use GitHub Actions for building Azure web apps. So this is going to be a really power-packed agenda. We have some amazing speakers, really great content. So if you have any questions that keep coming up, please feel free to drop them in the comments and the chat. And during these sessions, if there are some questions which come up, we will be taking a few of them. But due to the time restrictions, some of them we might have to answer it offline. All right. So moving on, what's new at GitHub? So there have been, various new things that has come up since our previous meetup that was on the 6th of October last month. So I'm going to take you through 5 things that have been new and something that you might probably want to watch out for. So the very first thing is GitHub Universe. So GitHub Universe is one of our conferences that happens annually, which is going virtual this year due to, well, all of us know, due to the pandemic. So at GitHub Universe, you can join people from GitHub, industry icons, and artists inspired by code for 3 days of live interactive sessions as we explore the future of software for developers, enterprises, and students. So this time, there's going to be a rebroadcast for the Asia Pacific region as well. That's comfortable for all of us out here in India. And this will have live hosts as well. So this is going to be from December 9th to 11th, a month away, and from 9:30 a.m. to 2 p.m. Indian Standard Time. So you can go and check out the schedule and the speakers at githubuniverse.com. So that was the first thing. The second thing, if you have been following along our blog or Twitter handle, you will get to know that GitHub docs are now open source. That's right. So whatever you see on docs.github.com, all the documentation is now open source and available on github.com/github/docs. So this is something that you can take a look at, and when you go on to any documentation article, and if you want to contribute, you can see towards the right side of that article, you can see a make a contribution button. You can click on that and you'll be taken to that specific page on the GitHub repo, and then you can create a pull request if you want to go ahead and improve it. So let's move on to the next thing. The third thing is an even better code review in GitHub for mobile. So there was a new release of GitHub for mobile that was there, which has multiple new features, including various different merge options, code options, jump to file, multi-line comments, and much more. Now, I know what most of you might be thinking. Mobile code? Really? Well, you'd be surprised to know that since launch, we've seen almost 700,000 reviews and over 350,000 merges. This is a lot of code to ship while you're on the go. So it's amazing what you can do, and we at GitHub really use it a lot as well for various different things on the go. And don't take my word for it. Here is someone who had tweeted out to us where they were merging automated PRs with GitHub's mobile app while boating with no electricity in the Brazilian Amazon rainforest, So it's really amazing what all you can do while on the move. That's really simple to do on the GitHub mobile app. So do check it out if you haven't already on github.com/mobile. So the next thing is, and this is for all of you, the JavaScript aficionados out there, is that NPM has a public roadmap. So we recently did announce the GitHub public roadmap as well. And similarly, NPM has a public roadmap. So you can go to github.com/npm/roadmap and take a look at what's new and what's coming up with NPM. And lastly, something really, really special for all of us developers and projects out here in India is many of the developers have been asking us that, hey, can you just tell us a little more about what are some of the projects that have been either created in India or those that have been contributed largely made in India. So we've curated a collection called the Made in India collection on GitHub collection of open source projects from India. So these I would like to really mention are just some of the projects from India. So if you know of any other really good projects that have been benefiting you, or someone that has made some really significant notable contributions to open source projects from India, this is again open source. Feel free to go ahead and open up a PR if you're really interested in contributing to this list of some really notable open source projects from India. And we are going to have later in the session today one of the projects speak up as well. That's right. We're going to have one of the well-known projects from India, the Hasura GraphQL engine, which is on the schedule, speak about their journey towards open source as well. So that's about it. 5 key things that's new since the last time that you have seen us all and spoken to all of us. So do watch out for more and stay tuned to our GitHub India Twitter handle, where we'll be sharing more about what GitHub India is up to, what the developers, maintainers, contributors, and our community here in India is up to. So definitely do tune in to some of the upcoming sessions as well that we'll have on our Meetup channel. So like I mentioned, if you have any questions or comments, etc., feel free to drop them in the chat window in the comments on YouTube Live, and we'll be taking those up wherever some of the sessions come in, or even in between that. So without any delay, I would like to first call upon our first speaker for today, which is Sadagopan Rajaram. All right. Sadagopan Rajaram is a senior director of software engineering here at GitHub, and he'll be talking about DevOps at GitHub, some of the culture, some of the practices, some of the tooling, and other things that we use to build GitHub, which would be really interesting and insightful for all of you. So let's welcome Sadagopan. Over to you, Sadagopan.
Thank you, Karan. Before I get started, a very quick introduction about me. I spent almost all my working career of 21 years building tools and services for developers, starting with compilers, IDE for devices, phone, and then developer services on test and reporting in Microsoft, and now I'm in GitHub. Okay. Over the course of this long career, I've seen software development, including my own, my own teams move from waterfall and client server applications. Then we saw agile and web and mobile applications, and now a lot of people are talking about microservices, serverless, and DevOps, right? While business has dictated a lot of this paradigm shift, one common theme that you will observe across all of these changes is that the goal was to make software development teams more productive, more efficient, more effective, right? And being part of GitHub is a great opportunity to interact and impact like millions of developers. And I'm really, really happy to be here sharing some of the thoughts that I have or whatever we have actually gone and think about DevOps and what we do within GitHub itself. So let's start with what is DevOps, right? I mean, just a quick intro. Most of you guys must have heard this or seen this multiple times. So this is primarily a refresher slide. There is a lot of great material on DevOps, and personally, I like the Phoenix project. The storytelling is very, very, it really resonated with me, and something that helps see the broader definition of DevOps than you would see in multiple places, right? As you can see, it's a cycle, and you can think of it as a game, and the goal of this game is to repeat the cycle faster and faster and deliver incremental value to the customer on a continuous basis, right? But it's more than just a business goal. In order for you to achieve this kind of fast incremental changes to customer, there is a change to process, right? And no process change is successful without getting people along. And DevOps really means breaking down the silos between the various stages. And that brings me to the first theme that you think about in DevOps and how we actually go operate in GitHub, right? So essentially, we want to go break down silos and then make sure that like collaboration within the team is like extremely high, right? For those of you in the waterfall model who have gone through this, would have seen the handoffs happening from planning to development to QA to release, and there is information loss in each transfer, right? And that automatically means that like whenever there are issues or fire drills, they end up actually causing a lot of chaos and churn in the overall teams. Now, in order to go fix this, some teams reorganize as DevOps engineers. In essence, like the same engineer is responsible for dev, test, and operations as well. Others look at consistency of workflows in dev and prod environment and centralized teams and so on, right? But if you look at like a little bit lower down the line, we really want to make sure that information flow is seamless across the project. And if you look at a lot of things that we do in GitHub, everything is done within a repo, everything is shared, and it's either a PR or an issue that we go and track. Interestingly, the conversation that I started like a month back with Karan on having this talk started off as an issue in a repo, and that's how we actually went and collaborated. Writing everything down promotes a lot of hyper transparency, which is a great team trait, right? One, it actually allows everybody to freely participate and automatically provides collaboration. Secondly, information is available when you need it and where you need it, and it's pretty much like centralized within the repo. And you're using pretty much the same tools that you're using for code or for issues like across the project. If you want to go create, let's say, an ADR design review change, then you go and do it on as a markdown file in the repo. If you want to go talk about like an event that you want to go do or a release, then you go create an issue and say, okay, here are the tasks that do it. And everybody in the team can actually go see the task and see how the progress is going on, jump in when required and stuff. This is my internalization of the word open source. And as I talked about, right, so this, and as I went through this talk, right, and given that we have a very short time, I really wanted to go and distill down and say, okay, what is it that we look at? And this is the one sentence that I really want to go think about when we think about collaboration, right? Write everything down. Now, once you have written everything down and you are actually gone and done the development, your idea is now you go take a look at the portion of the cycle of DevOps where we actually do the build and then deploy and then operate, right? Automate everything. Right. When I think about GitHub as a company, we have 1,000+ developers on the product. It is a globally distributed team. From a business goal perspective or from an engineering goal perspective, we update the github.com multiple times a day. I am really, really proud to say that the PR to continuous integration to deployment, one check-in from a developer can reach production within 2 hours. And that is something we are still saying is too long for us, right? And that I think is primarily the culture of going and saying, how do I shorten this cycle in every portion of the cycle of DevOps? Let's take a look a little bit deeper at the CI. And the idea is to make sure that like when I go check in a PR, do I have enough information and tests run on it to go and say, is this ready for development, deployment? At this point in time, the monolith in GitHub actually contains 7,000 test suites and 5,000 test fails. Every commit to a pull request triggers like around 25 CI jobs and requires 15 of them to complete before merging it itself. And for you to deploy, all the 25 must be complete. And this meant that for every commit, a developer at GitHub spent approximately around 45 minutes and 600 cores of computing resources. Now there is a significant amount of internal engineering we have done to get to this stage. So once you see this, like within 45 minutes, you can actually see whether you're ready to go deploy this particular check into production or not. The automation carries forward even further, that like any deployment of a build or a package is also completely automated, right? We are seeing that there are multiple tools in the market. One thing that I wanted to go talk about CI was something that was built ground up using Jenkins as a CI system. And over time, we have actually gone and made sure that this Jenkins evolved, and we are using Janky because the scale of what we are doing with Jenkins is extremely huge. And that I think is really the power of going and saying, let me solve a particular problem and see if I can actually go bring it out to other people to go use as well. So when I think about stage deployment, we are starting off whether with CI or CD with actions, and you will hear more about actions in the next few talks. It's a shameless plug for that. But we have a homegrown solution for deployment today. And this stage deployment actually goes and deploys to the infrastructure that we already have. It also goes and deploys to Azure Kubernetes clusters, which allows auto scale. And that I think is the primary thing of going and saying that can I do, again, automate as much as possible of what happens in the system, so that there is less scope for human error. We can continue to go make it faster. Once I have gone and deployed to production, the biggest thing that I want to go make sure is that everything is working fine. Now, before I go to production, I am going to go do a stage deployment. In essence, I'm not going to go take all my code and push it out into production. So we have a canary deployment that happens where roughly around 5 to 10% of the traffic actually comes in. And then we go and once we think everything looks fine as part of our monitoring, then we push it out to production. Even in monitoring, we can think about automatic alerts if there are things showing up in terms of some of the metrics that we actually go track. How are things going? And then we can make sure we can bring that back into the system. And we can continue to go evolve this to go make sure that we can do auto mitigation as well. So for certain kind of errors, you don't want the engineers to go come in and try to go fix it. You can try and do a mitigation effect. This is similar to what we do with auto scale. So for example, if a particular container is actually misbehaving, then we can just probably restart the container, right? And then we can go and debug and figure out. Now, one of the biggest things that you will notice about for those of you who have been in live site is mitigate first, and then you go and like figure out the root cause analysis and stuff, because you really want the service to be up online 24/7. The other thing that I want to call out is there is a significant amount of investment that has happened within GitHub for internal engineering. I mean, while I talk very proudly about these numbers of 2 hours, the fact that we are spending around 600 cores of computing resources for every commit, there was a lot of effort gone in to get to this stage. And it's also something that we want to continuously improve, right? The third thing that when we think about DevOps is really around continuous improvement. Now, when I think about continuous improvement, one of the biggest things that we need to focus on is the right metrics. Over the long course of my career, I have noticed that like we as software development teams get what we measure. There was a time in our career when we said, okay, bugs is a good measure of productivity, or the number of bugs that a developer could resolve. It didn't really work out, or the number of bugs that a QA engineer could actually file was a measure of QA productivity. That also doesn't really work out, right? I mean, you really need to look at like a much broader sense that goes beyond individuals and really looks at the overall system, right? So here are a few metrics that we are really looking at, right? I want to talk a little bit more about the lead time. I think the lead time is probably one of the things that you will see as a direct correlation to the cycle. How long does it take for me to go take a PR and then take it to production? Like we just talked a slide back saying that for GitHub, it roughly takes around 2 hours. But there are others also that we want to go make sure that like they can actually go once. How often do you deploy to production? How often does your deployment to production fail, right? How long does it take for you to restore back once you have a failure? And then when you're doing the service operation, you really want to go look at your availability and reliability numbers and build monitoring around all of them. So as part of your continuous improvement, you have to pick and choose the right metrics. And these are the ones that we have gone and like chosen within GitHub. And we are focused on making sure that we can continue to go improve this. For example, very recently, we took a look at our lead time. Our build time was contributing, as we talked about, for 45 minutes, right? By focusing on the customer requirements, in the recent past, the team was able to get this down to 15 minutes. And there was a lot of very deep analysis to go out and say that some of the tests that were running were being run for the enterprise server, which didn't really block the release for .com. And therefore, it could be a deferred compliance. So the team actually went and built an internal engineering tool to make sure that we could build this deferred compliance and make sure that we could use that as part of the entire pipeline. So, and the deferred pipeline would, the deferred compliance would actually file an issue. The issue would not block your deployment, but if the issue didn't get fixed within 72 hours, then automatically you would actually block all deployments to .com. So in some sense, we have actually used data from the previous set of releases and what we did, deep knowledge about the process and what the tests are to make sure that we can get this 45 minutes down to 15 minutes. The intent of actually sharing this is that you cannot stop at a particular process. There is no point in time when DevOps stops. So this is important to go understand that there is continuous improvement. But in all of this, I did not talk about microservices. I did not talk about cloud, right? So certainly architecture and design are very core pillars of the DevOps transformation. But I want us to go recognize that this is a journey. And when I really looked at like all the set of things that you could do in DevOps, should I move to microservices? Should I move to the cloud? We went and distilled down and said, okay, what really mattered for me being very proud of what GitHub is doing? These were these three things. That the fact that like we were very transparent about what we were doing, broken down silos and wrote everything down, spent a lot of effort in internal engineering on making sure that we could automate whatever we could automate, and finally like really look at what we are doing for continuous improvement. Moving to cloud is important. It certainly helps. But remember that like currently GitHub runs on its own infrastructure, and it also is on non-Kubernetes, and our engineering supports hybrid model as teams evolve. As teams evolve, then probably we are going more and more to the microservice model. We probably build more microservices. We might move some of those microservices to the cloud, but we are still running on the monolith. It should not block and say that we stop everything, do the re-architecture and move. And I think that is something that I want to take as a learning from this. It is a journey. We need to evolve. Where we start and what stages the evolution goes through will be very specific to your engineering team and your product. Breaking down monolith certainly helps in reducing lead time and fragility, but that's a large effort. It doesn't mean that I'm going to go stop everything and not start any other DevOps improvement until I can go do it, right? So that I think I really want to go take. In conclusion, DevOps is a very broad thing. It comprises of business, process, and people. In GitHub, we have sort of like looked at like a broad set of things and looked at metrics to go drive our improvements, looked at automating everything, and there's a culture of hyper transparency that promotes collaboration in the team. Questions?
All right. That was a great session, Sadagopan. Thanks a lot. I'm just, looking at the chat window. So there are a couple of questions. One is, okay. So one is, what are some of the tools used for monitoring at GitHub? So are there any specific, open source or other tools that we use for monitoring at GitHub?
So there are so there are some open source tools. Let me actually go dig up and find that out for you. And a lot of it we have actually built internal stuff on top of the existing tools itself.
Great. Also, I want to call out that the GitHub blog has an entire engineering section for itself, where you can go take a look at the various different blogs that the engineering team keeps on writing about, of certain challenges that how we are tackling, and how we are engineering certain parts of GitHub that you would be looking at. So definitely go take a look at the engineering blog. All right, so there's one more question, Sada, and then I think this is something that you can see on your screen. So Rishit asks, you talked about reducing build times for GitHub. Any tips you would give for optimizing their builds?
Can you share a little? Okay, so one second, let me just take a look at the question. You talked about reducing builds. Okay, so optimizing builds. there are a couple of things that we have actually gone and seen, and I think it's very specific to the kind of builds that you do. One easiest way to go optimize is to go parallelize. And if you look at some of the things that we have done in our CI system, especially when you're running tests as part of your build, parallelizing the run of tests across multiple machines and throwing more compute at it is one easy way to go and parallelize. The rest of the things that you actually go look at is to go and say if you can actually go use the more parallel build tools itself, and that is going to be the primary thing of actually getting your build times down. The second thing that I have noticed is, like, if you have very large legacy systems, as you continue to go pare down this thing, your service, for you to go deploy a particular change, you probably don't need to build everything. Invest in incremental build, invest in parallel builds, and those are two things that can actually help get your build times down.
Great. So there's quite many questions that are coming up. So I'm just going to take up one last question. There's a question on how can someone integrate an ML pipeline using the same CI/CD process.
So there is a blog on the engineering section corresponding to ML actions in GitHub. I think that's a great link. Karan, is it a good thing to go share it on the chat? Will that be something that gets to people, or?
Yes, you can please share it with me, and I can share this on the chat for the attendees.
Sure.
All right, so that winds up with our first session where Sadagopan was talking about some of the practices and some of the tooling that we use for DevOps here at GitHub. So thanks a lot, Sadagopan, for some of those insights.
Thank you, Karan, and thank you, everyone. Bye-bye.
All right, so that was Sadagopan talking about DevOps at GitHub, and our next session is by Petra, who is a senior developer advocate at AWS, and he'll be talking about how you can use GitHub Actions for deployment on AWS. So. So here we have Petra. Hi, Petra. Can you hear us all right?
Yes, I can hear you very clear.
Great. Thanks a lot. Thanks for joining us today. And over to you.
Come again? Sorry?
Over to you, Petra. You can start off.
Oh, okay. Yeah, okay. Hi, everyone. Thank you for the invitation to share about how we can use GitHub Actions to deploy container application on AWS. So yeah, a bit about myself. So my name is Petra Novadi Barus. I came from Indonesia. So I'm a senior developer advocate at AWS Indonesia. And prior to joining AWS, I co-founded my own startups on 2011, and then it got acquired on 2018. And then I've been a happy customer of AWS for 8 years, and I also used GitHub very extensively since 2011. I think even before that. And so if you if you want to contact me after this, you can contact me by Twitter or by Telegram or by Instagram. So I love to talk about startups and DevOps and modern application and also distributed system. So yeah, feel free to contact me. So what I'm going to talk about in this session, so I have 30 minutes, so I hope I can cover all of this. So I will go through a bit on containers on AWS and what container services that you can use on AWS, and then I will also share about a bit about Amazon Elastic Container Service, where you can deploy your container application on AWS, and then what is AWS for GitHub Actions and how do you use it? And then at last session, in the end of the session, I will do some demo where you can see me deploy a containers application onto AWS using AWS for GitHub Action. So I think most of you already know about containers, so I won't well into much more technical side of it. So, but why are enterprises adopting containers, and why containers is so sexy? So there are a couple of reasons. So first one is we can use containers to accelerate software development because now in modern applications, are shifting to cloud native and microservice architecture, and containers are a perfect way to encapsulate these pieces of units to into a portable unit. So now, the development methodologies are changing with developers shifting to agile methods, and containers being a lightweight and then portable. This is a very good vessel where we can wipe the code and then we can push the code to the production, and then we can also use containers to migrate our legacy applications to modern applications, because we don't need a lot of refactoring, since we can wrap all of the legacy code into containers, and then we can deploy it to productions. And also the last one is we can automate operations by using containers, by using the containers orchestration and management system. So we can deploy and manage distributed and cloud applications by using those microservice containers orchestration system. So what are typical use cases for containers? So most of developers are using containers to develop microservices, such as you can wrap a Java application or Node.js application or Go application or my favorite PHP applications, and then you can also push all of the container image. You can easily integrate into CI/CD process by building the container image and pushing it to the container orchestrations, and then you can also do a batch processing and ETL jobs by using containers. And a lot of use cases here, you can do a migration from legacy into cloud, and then you can also deploy AI ML applications by using containers. And okay, so AWS, we have missions to be the best place for our customers to build containers applications. So we have a lot of options for our customers to develop containerized applications, and from start you can choose between two services to manage to orchestrate your containerized applications. By firstly, you can use Amazon Elastic Container Service, or Amazon ECS is containerized microservice container orchestration service, where it's really integrated with AWS services. And then if you are more into Kubernetes, you can also choose Amazon Elastic Container Service for Kubernetes, or Amazon Elastic Kubernetes Service, Amazon AKS. So you can deploy your Kubernetes application into AWS. And then for hosting the container itself, you can choose between the Amazon EC2, which is the instance, and then you can also choose AWS Fargate, where you don't need to manage the infrastructure on the underlying container. So yeah, if you choose Amazon EC2, you need to maintain the infrastructure, the software. You need to upgrade the operating system. You also need to patch the underlying operating system. But if you use AWS Fargate, you just you can just focus on building the application itself. And then lastly, we also provide image registry, where you can store your container image into AWS securely and safely. And so this is a bit about Amazon Elastic Container Service. So Amazon Elastic Container Service is a container orchestration service where you can manage your containerized application very easy. So here, the components of ECS are the scheduling and orchestrations, and the cluster management and the placement engine play specific roles to help accomplish how we can schedule and orchestrate the container itself. So the cluster manager manages half of the instances within your cluster, and you can also set up an auto scaling group and register your instances within your cluster. So ECS is then aware of the capacity that you desire for your containers. And then the placement engine, on the other hand, they enables techniques on how you want to place your containers into EC2 instance. So for example, if you want to certain tasks to use certain server instance types, or you can desire super efficient packing for better economics, and then this will be helped by the placement engines. So here's how the structure of ECS. So so first we have the container definition that we describe what kind of container that we use, and then for example what CPU limit or memory limit that we want to have, and then it will be wrapped into a task definition where we can wrap multiple containers into one task. So and then so like these multiple tasks can be like can be run within like one service, and then we define this in the service definition. So yeah, so a service will allow you to run and maintain a specific number, or we call it desired count of simultaneous instances of task definition in ECS cluster. So and then after we deploy, and then we can deploy, we can choose to deploy this task with Amazon EC2 or AWS Fargate. So yeah, if you use Amazon EC2 to deploy your containers, you will have to you will have to maintain the underlying EC2 instances by upgrading the operating system, upgrading the ECS agents, and upgrading the Docker engine. But then, if you choose to use AWS Fargate, you don't need to, maintain all of the EC2, the underlying EC2, because it will be maintained by AWS. So you don't need you can just focus on building the container application itself. Okay, so that's a bit about Amazon ECS, and now I'm going to share about AWS for GitHub Actions. Yeah, so we released the AWS for GitHub Actions is a set of GitHub Actions that you can use to deploy and maintain your application with AWS. So they are first released on the 14th of November at GitHub Universe 2011. So and it was started by 4 GitHub Actions to deploy your application to Amazon ECS and Amazon ECR. And now we have like more than almost I think like double than that. So you can see the list of AWS for GitHub Actions here in the github.com. In the github.com/AWS actions. So there you go. Sorry. Yeah, so we have a lot of we have a set of AWS GitHub actions that you can use to deploy your application into AWS. So I will in the next demo I will use 4 of these GitHub actions to to give you some sense on how to use these GitHub actions for deploying your application to Amazon ECS and by using then Amazon ECR. Okay, so yeah, you can. So first we have this configure AWS credentials where you can retrieve the AWS credential from GitHub secrets to your GitHub workflow, and then after that we will use Amazon ECR login to login our GitHub workflow into ECR, so we can pull the image or we can push the image, and then after that we will use the Amazon ECS render task definition to recreate a task definition JSON, so for the to be updated, so we can update the ECS cluster into the Amazon ECS, and then after we generate the container the task definition, then we use the Amazon ECS deploy task definition to update the task definition and image into ECS service. Okay, so yeah, here's a bit on the demo. So you can access the demo in my GitHub. So github.com/petrabaru/aws-sample deploy ECS GitHub actions. So here's what you can see. Okay, so I lost my mouse. Okay, so here's a bit the structure on the repo. So we have this directory to store the workflow. So you can see here in the action.yaml. And then here I have a AWS CDK, the CDK definition that will define our AWS resources that we need to have to deploy the applications. And then for the application itself, I will only have a very simple Docker definition, which is the Nginx, which only contains Nginx, and we will update this index.html to see, like whether we can update the application or not. So yeah, going to the AWS CDK. So this CDK is a is a infrastructure as a code where you can define resources on AWS that you will need for deploying your application on AWS. So here I will define an IAM user. So for this IAM user, we'll need this IAM user for our GitHub to access our resources on AWS. So we will have this IAM user, and then we will have this access key that we will store in the GitHub secrets. And then after that, we will put the ECR repository here. So this is where we store our container image, where we then deploy the container image. And then after that, we will create our ECS cluster. This will contain all of the tasks and services where we deploy our applications. And then here I will have this ECS service. This will be the service that we can where the application will be deployed. So here's the asset. Okay. So you can access the application here, and after I generate the code, after I generate all of the resources, I will put some of the information like the access key ID, and then the access key secret, and then also the cluster name and ECR repository, and then the task definition to GitHub secrets. Okay, so here you go. So yeah, so I will store this secret key here, access and secret key, and then the cluster name, and the ECR registry, and then also the service name where I want to deploy the AWS service, the ECR service, and then this is the task definition family where I want to obtain the task definition so I can update with the new image. And yeah, after reviewing this CDK, now I'm going to review the GitHub action workflow. So here I have 7 steps, starting from the checkout, where this is a pretty basic checkout, where we check out the code into the GitHub actions. And then after that, we'll use the GitHub actions for AWS for GitHub actions to configure the AWS credential. So in this action, we will obtain we will obtain the AWS secret key from the secrets that we already stored. And then we'll also store the access key ID and then access key secret, and then we also store the AWS region here. And then after that, after we obtain the access key, we then log into Amazon ECR. So I already have, after I deploy the ECR, the CDK, so I will have this users. I have an IAM user here. It's already have a certain permission where I can, where the GitHub action can deploy and can interact with all of the AWS resources. And then this is the cluster that I already provisions through the AWS CDK. So here you can see we have one Fargate already running, and then we can also see the service that's running here. And then for the ECR, this is the ECR that's generated by the CDK code. So here I already push one image to this ECR. Okay, and then what's next? Okay, so yeah, coming back to the action. So after I log into ECR by using the Amazon ECR login actions, then I will do a step to build the image, the Docker image that's stored in the Docker file, and then I will push it to the ECR repository. And then after that, I will get, so I will obtain the task definition from the ECS cluster that I already provisioned, so that we can update it using the new container image that we already built. So here in the next step, I will then I will also use the AWS for GitHub Actions, which is the AWS ECS render task definition, and then here it will replace the image that is in the task definition with the newest image that we already built. And then after that, this task definition will be passed into the next step, which is the deploy to Amazon ECS service. So so in this step, I will also use the AWS for GitHub Actions again, which is the Amazon ECS deploy task definition. So here I will use the new task definition, and then I will target the service that already stored, whose name already stored in the secrets, and then I will also target the cluster whose name also I already stored in the secrets. Okay, now I'm going to update the code. So here's the code. Okay. So here's the Docker file. So we can we can run it in the local. So I already built it in the local. Okay. Yeah, I'll just skip this part then. So here I will I will bump the code. So I have this hello world 3 here. Hello world 3, and then I will bump into hello world 4. So here I will commit the code. And then after I commit the code, I will push it to GitHub. Okay, so you can see in GitHub here in my repository, you can see as soon as I push it to the master. Okay, yeah, I will zoom it. Okay, okay. So as soon as I push into the code, push code into the GitHub, it will trigger the AWS. It will trigger the GitHub Actions here, and you can see here's the steps. So so here I already configure the AWS credentials by obtaining the access from the secrets, and then here I'm going to build build the Docker image. So yeah, so this takes a while. So yeah, once we finish building the image, it will reflected in the ECR. So now you can see it's already pushed into the repo, right? Okay, so okay, yeah, so it's pretty fast. We just need like 20 seconds to push it into the Amazon ECS. So you can see here in our service we already have 2 running tasks here. You can see in the deployments. Yeah, it's currently updating the current service to use the new task definition. Okay. So yeah, now you can see it's already updated. So we used to have the hello world 3, and then now we have a hello world 4. Yeah, so this is a very simple demo, and you can access the code here in my repository. So yeah, as you can see in the CDK, I put the CDK in the same code base because one of the best practices in DevOps is to put all of your the infrastructure definition, documentation, and also sample data in the same code base with the applications. Okay, Karan, I think that's all for me. A quick demo on how to deploy the containers application to AWS using GitHub Actions. So yeah, back to you.
Thanks a lot, Petra. That was, that was a really useful session on how you can use GitHub Actions to deploy to AWS. There is one question, and after that we can probably move on to the next session. So there's a question, on whether to deploy, you need to use ECR itself, or you can use some other container registry as well.
Well, yeah, so you can use either you can use both either by using existing container registry like Docker Hub, and then also you can also use the Amazon ECR, because like there are some limitations by using Docker Hub, and then so for ECR, is much more flexible. And also, I think we did announcements today that we are going to have a public registry for Amazon ECR as well. So yeah, and then Amazon ECR is much more integrated with the other AWS services like the IAM, just like I demoed. So here I have the IAM. So here I have the IAM have I put the permission for the IAM to access the Amazon ECR. So it's much more like integrated within AWS services. Whereas if you use like external container registry, you will need to like put more configurations into the code.
Great. Thanks a lot, Petra, and thanks for joining us today and sharing more insights of how you can use GitHub Actions along with AWS, and also for that demo. So thanks once again, Petra. All right, so that was Petra, who is a senior developer advocate at AWS. Now, switching gears a little bit, let's talk about open source. So we have, like how I mentioned early on, one of the co-founders of a project, the Hasura GraphQL engine, talk about their journey towards open source and how they went about building that project. So I would like to bring on live Rajoshi, who is the co-founder of Hasura, who has built the GraphQL engine and also has an open source project to it, which has a lot of stars on GitHub. So hello, Rajoshi, and thanks for joining us today.
Hi, Karan. Thank you so much for having me. Really excited to be here, and thanks everybody for tuning in. Yeah, I am looking forward to sort of sharing a little bit of the Hasura story with you all.
Great, thanks. Rajoshi, you can go ahead and share your screen, and I can bring on your presentation.
Awesome, sounds good. Just give me a moment there.
Sure.
Yep.
All right, over to you, Rajoshi.
So thanks again, Karan. And yeah, so I'm here today to share a little bit about the Hasura journey with you all. Starting off, I'm Rajoshi. I'm one of the co-founders at Hasura. And I come from a genomics and bioinformatics background. So I worked with biodiesel for a bunch of time. And now I work with data access infrastructure, but that's a story for another time. You can find me on all the different social media places at Rajoshi Ghosh. So, feel free to reach out to me if I can be helpful in anything. Moving on to, Hasura. We're an open source technology startup. We have offices in SF and Bangalore, and we have people working with us and our community spread over many, many cities across the whole world, and that's pretty exciting. We launched Hasura as an open source project in 2018, and we've been one of the fastest growing open source projects in the GraphQL space. And we've seen this sort of bottom-up developer traction, not just with with developers across all kinds of companies and communities, and from sort of like your coffee shop startup all the way to Fortune 500, and sort of seen that growth happen over the last 2 years. And I'm going to talk a little bit about that in this talk. We've been backed by some really good VCs who've helped us in our journey, sort of will be part of the journey going forward as well. So what does Hasura do? Hasura basically is a product that, like I said, data access infrastructure. It makes data access easy for developers, and makes data access scalable and secure for the business. So how that works is basically, you put Hasura on your stack, pointed to your data, and Hasura makes your data available as a service, as easily consumable GraphQL APIs. So we give you instant GraphQL on your data. And why this is, interesting, for companies and people building products is that your data today can be anywhere. You have your data in your databases. You could have part of your data in, say, you're building some kind of checkout experience. Part of your data is probably in Stripe. So your data is in your database, your user data is in your database, you have Stripe, you probably have some data in some authentication provider, you're probably using a CMS for something, you're using Salesforce. So data, building an application is spread across lots of different data sources, and sort of accessing data from these data sources can become a bottleneck pretty quickly. And so that's the part that Hasura sort of steps in. You sort of create relationships between these these pieces of data, and you get to access this easily with an API, a GraphQL API that has a beautiful developer experience around it. So how did it start? We actually started way before Hasura, the open source project. A lot of people in the team were part of a consulting company that, we ran out of this tiny little flat in Besanagar in Chennai, which is in the south of India. And, we wanted to make development, make application development easy, but we weren't really sure what shape or format that would take, right? So we sort of decided to go ahead and build a lot of products for lots of different companies, starting off with local startups, moving on to some large banks that we worked with, experimented with a lot of technologies, became part of lots of open source communities, and sort of like the journey began for us there as we tried to figure out and make sense of what would making application development easy, really look like. And so what we came up with at that point was this Hasura platform. And this, predates the Hasura product by a few years. And, we had this consulting team, we had this team of engineers who loved the experience. We could ship apps much faster than anybody else, and we absolutely loved the experience. What this product was like a combination of a Heroku and a Firebase. So you had all these instant APIs, auth and file storage APIs, and your data APIs, and you kind of had like an easy deployment option with like Heroku on it. And this was entirely packaged on Kubernetes. So it was a great experience for our developers. We were very excited to take it to market. And, we sort of decided that we would, take away this product, start the product company, which we did. And things are going to be like really rosy. And so basically, just a quick segue here about, you're wondering why the little brio is here, because that's how we traveled around as a team, when we were working there. And we decided when we started putting this platform together, what's this? What should we name it? And somebody said Demon, and we said Asura Demon. So for a lot of you, since this is on the GitHub India channel, a lot of you probably seen this motif. It's a very common motif, not just in India, but a lot of South Asia and Southeast Asia actually. Which is, the demon motif. And we added an H to it, which is Hasura, because, a big part of our code base is in Haskell. And this was, the adding H to it and Hasura came together in this little car when we were driving around. And Karthik, one of our first engineers who joined us, was like, hey, let's add an H. And Hasura, we're like, everybody. It was like a 3-minute decision, right? But that's kind of how a lot of decisions get made along the startup journey. But so yeah, we really had a great experience with this platform. And then, we took that to market, and it wasn't the reception wasn't as exciting as we wanted it to be. There was good reaction, which is what like kept us going with it for a while. But we quickly realized that people weren't really using it for things that were critical, and like projects that they would like build in their companies, and projects that they would like that would support users and whatnot. And so and I'll come into like the lessons that we learned from that. But basically what happened is we were still working on this, and we were in San Francisco and decided to sponsor. There was a React a React hackathon and a conference coming up, and we were like, we should do something exciting. What's exciting right now in the developer ecosystem? And then we were like, hey, GraphQL. Though GraphQL was around for 3 years at this point, we were like, you know what? We can add a GraphQL API to our data APIs pretty quickly, and so let's use that and prototype that and demo that at this conference, and get people to try it out at the hackathon. So this gave us like, it was just a demo, it was just a prototype that people could try out, but our team shipped this. It was 2 weeks to the conference, quickly got it out, demoed it, and got to spend a lot of time with people who were trying things out with this was Hasura platform plus GraphQL. And what we learned during this experience is that people really liked the platform that we built together. People really liked the individual pieces. And what really resonated with people was this instant GraphQL, which was enabling data access, right? So we saw that from talking to people at this conference, which had some of the best people across lots of different companies working on mission critical software. What we also saw was that the platform was too many opinions. It was too much packed into, too many decisions for somebody to sign on to, which was great for like our team. That was all, we were all using that platform. It was great, but in a real world scenario, people have made technology choices, right? People have decided what to use for auth. People have decided what to use for file storage. It's a big decision to come and sort of replace and wipe out everything and, like replace a huge chunk. You can replace a small portion and do that really well. And so this platform had too many things baked in, right? So we could see that it would be great for small projects, but it's not going to scale to a big business. So that was kind of, what we learned from this. So what we did from there is, like you said, like I just said, focus on one piece and really make it easy to get started. So what happened from there is we took this piece, we spoke about it, we blogged about it, this was, and then, 2 months into it, we got our first inquiry from a Fortune 500 company saying, hey, is Hasura available on-prem? And we're like, yes, it is. Talk to us more. And we started the conversation with what became our first enterprise user, right? And so all of this actually happened before we launched the Hasura GraphQL engine. We spent several months talking to people in the GraphQL ecosystem, really understood the value, like took our learnings from that conference and sort of understood the value of, of what the value we could add to other businesses, and then really focused on the developer experience, like that 0 to GraphQL has to be absolutely amazing, has to be super fast, and nothing gets in the way of that, right? So then we focused on that from like March to July, and then launched it, and we got on Hacker News, got like people started talking about it. But that's great, but to sustain that, you kind of need to keep focusing on those things that we learned on while launching this, because otherwise it's again going to be that project great, one day on Hacker News and then what? So we really continued to focus on the developer experience and a few other things which I'll just talk about. So this was the developer experience bit, sparking joy, which was important then and it's important now, and that's the kind of stuff that this is the kind of feedback that also makes it great to work on an open source project where the community is involved, they're sort of acknowledging and trying it out and sort of really giving you helping you along in the journey in some sense, right? So these are moments that make everyone on the team super happy. But like I said, it's great with an open source project when you're getting that adoption and getting that developer love. But to make a business out of it, you really need to get that mission critical adoption. You need to be an irreplaceable part of someone's infrastructure, right? That is mission critical. So that was also super important to us. Like there was the developer experience and then really getting mission critical adoption and helping people get productive very quickly and helping them sort of service their users, right? And so these are some snapshots of people who've come and spoken about their experiences using Hasura in production. So we had like the solution architect at Philips Healthcare who has over 26 years of experience, who basically talks about how Hasura became a central part of their infrastructure. They spoke at the HasuraCon conference that we had earlier this year. Similarly, Ryan from Airbus also speaks about how they built a platform on Hasura. Optum, which is one of the top 10 Fortune 10 companies in the world, speaks about how they're undergoing a whole digital transformation with GraphQL and Hasura today. So this was also very important to us. And finally, one of the things that, this whole community-driven development that we have going is also like this ridiculous support mode. We're getting a lot of feedback from the community in terms of, GitHub issues and people giving us feedback, which is great. And, that that focus on supporting our users is something that really makes, helps us build the community and kind of keeps that momentum going. That one launch is not going to make it, but it's that continuous support that is sort of like helped us stay close to our users, listen to them, and sort of add add things, help the kind of information that we're getting from the community to inform our roadmap. So that brings us to Hasura today. We continue to focus on developer experience. We continue to focus on mission critical users, and we continue to add different data sources. So today Hasura supports other REST and GraphQL servers, third-party APIs. We have Postgres as the primary database that we support, but we have MySQL and SQL Server that are coming soon, and many more databases that we will keep adding going forward. So that's a little bit about the Hasura journey. So moving on to sort of the second part that I wanted to talk about today, which is what is how for all of you watching in, like what are the kinds of things that that you can do to sort of be involved with open source and make a step in this, take a step in this direction. So one of the things is focus on creating value and don't worry about what's the best possible version of the software that you can put out into the into the universe, right? So don't, if you are someone who's looking at creating software and you like creating software, don't wait till your the tool or the product that you're building solves all of the problems. Focus on one thing that it does well and go out there and put it out, right? That's kind of the beauty of open source software as well, and community building up around it. So you don't need to wait till your product does X and Y and Z and wait till Z and maybe like 10 other things before you launch. But once you do X well, go ahead and launch X, right? Like go ahead and put that out. Start building a community. And there's a lot of talk around like, learning in public and building in public. And these are nice examples to sort of look at. Similarly, as consumers of open source software, when you look at something, when you want to try and solve a problem, look for things that solve a problem well, right? I mean, this is that sort of ecosystem. So, if something solves one particular problem really well for you, don't wait. I mean, don't sort of barrage the, like the person building the software for 10 other things that it can do. And if this works well, build around it. The one X working well for you is probably going to shave off months of development work anyway. And so you can build things around it. And maybe when that product also has the Y and Z that you've built, you can take a decision on whether it makes sense for you to replace the Y and Z with what the product has come up with, or stick with what you've built. That's your call. But if X is helping you move forward, then take X and move forward, right? That's kind of the healthy ecosystem that that would be really good to be a part of. So this is kind of just adding on to it, which is about give feedback. If you're an early adopter, give feedback, try things out, be constructive. People might get a little bit salesy, realize that there's a good intent behind that, and sort of like these are like small learnings which makes this entire experience joyful for people. The second thing is participate. I spoke about this a little bit, and it's really great both from when you're creating as well as when you're consuming software. Talk about what you're building. Don't build in isolation and wait for like that final moment when you want to talk about it, involve the community, and don't just consume, contribute. If you figured out something, help other people figure that out, on online forums, and organize things in your company or like your university, or on showcasing cool new software that you discover. So become a part of the community and participate. And this is completely orthogonal to whether you're creating software or not, right? You can do this today, right? Nothing is stopping you from like contributing and being a part of the community. And finally, like be vocal. This is again like a continuation. Like talk about the software that you're using. Talk about like there are people who are just consuming, and so if you want to help them sort of by talking about the kinds of things you're using, then it helps people sort of understand, check out new software, talk about why you're doing it, not just what you're using, and sort of be part of that learning culture. And finally, fight the small battles, right? Convince, if you're working in a large company, which is a closed source company, there's small tooling, like some of the best open source tooling comes out of companies that are building something completely different, right? Because people are continuously building software to optimize their work. So if there are pieces of software that you're building in your company that can be open sourced, and it can you can contribute to the ecosystem, then fight those battles. And if there are open source contributors out there, support them and help them out. And I think lots of programs are coming out to kind of do this, and so be a part of that and recognize people's work, and be even if you're not actively participating. Finally, to sort of wrap up, for those of you interested in learning more about Hasura and GraphQL, we have a bunch of GraphQL resources for you that you can get started off. We recently, started trying out GitHub discussions. So, you'll find us on GitHub discussions and Discord. And, we have a newsletter where we send out updates once a month. So that's another thing. And my final slide for today is that we're also hiring. We have a bunch of open positions across engineering, developer advocacy, design, marketing. So for those of you tuning in, if you're interested, check out our careers page. That's it from me. Thank you so much, and really enjoyed being here again.
All right. Thanks a lot, Rajoshi, for sharing your journey of building GraphQL engine, and also how you went about building the project and monetizing it, etc. So there are a few questions which are coming in on the chat, but unfortunately we're running a few minutes late. But pretty sure that Rajoshi is going to come back and then take a look at some of the questions. And she also mentioned about some of the forums where you can reach out to her and the Hasura team to chat more about what's on the roadmap. So thanks a lot, Rajoshi, again for joining us today.
Thank you so much, Karan. Thanks a lot for having me, and thanks for tuning in, everybody. See ya.
Thank you. All right, so that was your Rajoshi, who is the co-founder of the Hasura project. The GraphQL engine right now has close to 20,000 stars on GitHub and is growing rapidly, like how she mentioned. All right, so moving on, back to DevOps with GitHub, we have our next speaker, talking about serverless deployments using Google Cloud Run and GitHub. So I'd like to bring on Dharmesh. So Dharmesh is a Google developer expert for cloud, and he'll be talking to us today about how you can use the Google Cloud Platform and also GitHub for serverless deployments on Cloud Run. Hi, Dharmesh.
Hey, hi Karan, how are you doing? Thank you so much for inviting me.
Doing good, thanks. Thanks a lot for joining us, Dharmesh, and over to you.
Thank you so much. All right, hi everyone. Hope you all are having a fantastic time attending these virtual sessions in whatever capacity. I'm sure like you all have had a continuous learning experience with these sessions that are being conducted across the globe. So today's talk, we're going to see around serverless deployments on Cloud Run using GitHub, and we'll see what all other features does GitHub provide in terms of how you can make your product lifecycle more and more efficient and improvised in terms of, say, maybe logging, reporting, any kind of notifications, and so on. Before that, a quick introduction again. I'm Dharmesh. I am the Director of Technology at Agraya Technologies. We are a voice plus cloud agency, and we work with different partners, providers in terms of providing cloud and voice solutions. We are also a GCP partner. And as Karan mentioned, I'm a Google developer expert for cloud and payment systems. I speak, write at different conferences. So feel free to reach out if you all have any speaking engagements to be done. With that, let us get started. And I'm sure like you all have already had some background around what is CI, CD, and what does deployment look like when it comes to any platform, or especially when using GitHub. So I won't waste too much time into that, and will give you a very quick walkthrough that what exactly does CI and CD mean for you. Okay, so if you see these two circles of, just call them like circle of life or circle of software development, it's actually the whole basis of how software gets developed and deployed or shipped to an end consumer or an end user. So the first phase of it is basically the CI piece that we'll be talking about, which is basically the planning phase, the coding part of it, the testing piece of it, and then if the testing gate is actually positive, it actually moves to the next piece, which is into the release, deployment, and the operational part of it, which is more of the day two cloud operations. So that is where the delivery aspect comes into picture, and we'll see that how exactly, maybe using any tool solutions, your whole journey around CI/CD becomes much simpler. And there are ample solutions or ample tools available, but specifically talking of, say for example, on Google Cloud, how you can achieve CI/CD in a very fast automated manner, and of course like using GitHub as your source repository, and some additional features of GitHub that can aid to your product development lifecycle. So you as a developer, you're going to commit changes onto GitHub, or it can be like any other repository where your source is getting managed. This actually triggers a build, and this build actually will get triggered in the form of, say for example, if you're doing a containerized application, it tries to make or develop a container image and then push it onto container registry, where actually your containers, the latest images of those containers are being stored, and then it is going to get deployed in either Cloud Run or a compute engine or anywhere. So likewise, like how we saw in the AWS example, if it is getting installed into an EC2, here you can similarly do it on a GCE or a Cloud Run instance as well. So not a Cloud Run instance, a Cloud Run service as such. So the whole life cycle of any CI/CD looks very much similar. But then what exactly is the speed or scalability factors that we talk about? So if we talk in terms of like serverless deployment, so you as a developer are not really worried about where does it get deployed. You are worried about the functionality, you are worried more about how it is getting deployed, whether your testing team, whether your product manager is getting the right update or not. You're worried more about those aspects and less on the infrastructure pieces. So with that, Cloud Run is a potential way, I mean, in terms of serverless deployments, wherein as a developer, you push your code and a build is getting triggered on GitHub. Now, how does it get triggered? It can be either using actions, GitHub actions, which are readily available. You can, using GitHub actions, you can kind of wait for a push to occur. As soon as a push occurs, you can start creating or you can start developing the Docker image for that. That Docker image can be then pushed to the GitHub container registry, or it can be the Google container registry, and then deployed into any of the compute platforms. So ultimately, a compute platform will somewhere or the other place be required. But how do we abstract away these layers of infrastructure from a developer so that they can worry more about the product development lifecycle and its features and its functionalities? That is where features or products or solutions like Cloud Build, GitHub triggers or GitHub actions would come into picture, wherein your workflows are so seamless that you won't have to actually worry about where it is getting deployed, how it is getting deployed. And once the trigger has been initiated and the build has been done, your image, once it is ready, it gets pushed into the container registry. Now, you might ask whether this has to be a container registry or it can be the Docker registry itself. Yes, it can be the global registry also. But then in that case, the configurations for Cloud Run will not work as it is shown in this figure. You'll have to use another compute platform or something else to deploy that. So in this case, if I have to talk about this flow, as soon as a developer pushes the code, a trigger occurs on GitHub. Cloud Build uses the code base to kind of create the Docker image. This image is then pushed to the container registry, and Cloud Run then comes to know using Cloud Build that, okay, I need to go and do a deployment. Let's pull the latest image from container registry. That's how the latest code will get deployed on Cloud Run, and then it kind of serves to the entire traffic. And of course, like these will be like HTTP servings that can happen. So you can kind of also link your domains if required. So if I have to summarize more from how the deployment process looks like, it is as simple as this. So what you see, the green blocks over here is more the CI pieces, which is the continuous integration pieces. And this pink block or the purple block that you are seeing over here is more of the delivery pieces, which is the delivery pipeline. So a developer, you change your code, push it to your container, push it to your source code repository. The source repositories actually detect the new commit, and we'll be seeing in one of the demos that how exactly using GitHub Actions we are polling for a change in the code base, or whether a push has occurred, or you can also do a scheduled run over there. So once this new commit has been detected, you can either run test or build the container image. This container image gets pushed to the registries, and then from here it actually detects the cloud build. I mean, specifically talking from the GCP perspective, if a candidate branch has changed, which means a new build has occurred, that means that you can go ahead and deploy this to either Kubernetes or any of the deployment or the delivery pipelines that you have configured. And likewise, you can update that into the production using the required manifest. So the overall process, if I have to kind of justify and summarize, okay, it's basically a developer pushes the code, a container image gets created, developed, and then pushes onto the container registry, and then that is getting deployed at any of the compute platforms. So essentially, even if it is a serverless or a non-serverless deployment, the process remains almost the same. It's just the difference in the matter of the way in which it is getting deployed and where it is getting deployed. So what is actually used in this case, like here we showcase more from the CD perspective. There is something called as Cloud Build, which kind of helps you any Cloud Run service, if you want to set it up with Cloud Build, which is more to do with the continuous deployment aspects. Here you are going to actually link your source repositories. Now, as one of the major repositories provider, GitHub is obviously present in this configuration. You just have to specify which repository you want to point to, with of course all the possible roles and configurations done in terms of IAM, that, and then you specify which branch and which Docker file you want to point to. Once this is done, it's actually ready to be deployed on Cloud Run. What exactly is Cloud Run is basically it's actually a serverless compute platform, I would say. You can write your code or application in any language, any library, and as far as your application can be containerized, you can deploy it in a serverless manner on Cloud Run. And of course, it is managed. You don't have to worry about its internal configuration, its auto scaling factors, and so on. And it really provides a very cost efficient billing as such. So how does it actually work? So when a web application gets a request and it is being served from Cloud Run, what happens is it will be serving like different revisions, okay, or you can call it as different versions of the applications can be made live, just like the blue-green deployments that Sadagopan talked about a while back. So in this case, like if service A gets a request, you will see that the container instance for that is being spinned up. Now, yes, there can be certain cold starts to this, but that can be avoided by appropriate triggers and polling mechanisms, and you won't have a cold start over there. So over here, if you're seeing that service B is not getting any request on this GCP project, and you will see that no container instances are being developed. Likewise for it's the service A revision A1, A2 as well. So which means that containers for these services are not running, are not being deployed, and it's a really cost efficient way of deploying, and you only run the container for as much time the request is hitting the application. After that, it kind of scales down to almost like zero. So if I have to talk about like GitHub Actions and how it actually gets linked, so you all know that using GitHub Actions you can configure your Docker images, or you can kind of keep on polling for any build and then continuously deploy that. But what beyond CI and CD? Does CI CD just ends with actually deploying your application, or is it something more? So it actually does not really end with just CI/CD. Your product development lifecycle is not just giving a piece of code and deploying it. There is a lot more layers to it, especially when it comes to operations. And it actually deals with a lot of things around logging, reporting, scheduling as such. And you need to have appropriate notifications as well. So if I talk in terms of these lines, it's actually more towards the SRE principles as well. And I'll share some references which will actually, if someone is really keen on taking the SRE journey, those are some ready references available. So how does then GitHub provide you all these features and functionalities if, say, for example, it is really cloud agnostic, right? So GitHub in itself is a mechanism or a platform that can help you achieve an entire CI/CD as well as a layer of SRE for your applications. Now, what are some of these features that you can use? So specifically talking from a GitHub action perspective, one of the most underrated one, I would say, or don't call this like spammy as such, but yeah, this is more with like integration with Slack or any platform as such. Now, you see over here that if at all you have configured this for any of the Slack channels, uh, any code base that you have, you can configure such that if any push that you do on your code base, you will get a notification of Slack that who has committed, what is the URL for that, and specifically if any message or any notification has to be provided. Now, how to achieve this? There is ready available GitHub Actions available. You just have to kind of use them and then deploy them into your workflows. How to do that? We'll just see it in a while. Another one is basically scheduling. Now, say for example, your application has kind of matured enough, or even if it is pretty new, and you want to ensure that your application is getting always the latest build, or the latest code base is always serving. So you don't want to wait for a particular time, or you don't want to manually kind of trigger that. Of course, you can kind of you know you can always like kind of do that in terms of like scheduling as such. So what will happen over here is that any schedule that you want to configure, you can do it as a cron using GitHub Actions itself. So it is as simple as writing a cron string as such into your YAML files. Okay, now this is as simple as just specifying on schedule, and you just specify cron. Now this is very simple to achieve. Let us see in terms of like whether you can do it with on a particular branch, or you have to configure it separately. How does that happen? Let's see that in the form of a demo. So let me share my screen for the demo. Okay, now that's basically my repository that I'll be using. And if you see over here right now, this one is basically serving this is already deployed on Cloud Run. Now let us try to make a change on this repo and see whether I get it deployed immediately, whether I kind of see it in terms of any Slack notifications and so on. So let us make a very simple small change on this application. I know this is not the best way to kind of use GitHub, but yeah, let's demo for GitHub virtual meetup. Okay, for demo. Okay, and I commit my change. As soon as I commit this change over here, you'll see that on my Cloud Run instance, okay, I would be seeing a lot of activity that will happen now. Now, even if I have like configured Cloud Build, okay, it can also be kind of configured for using any actions, and you will see that as soon as I pushed it, this got activated, which is the push trigger. Now let us see what actually happens when a push trigger has happened, and you'll see that okay, I haven't shared my Slack window, but yes, I also got a Slack notification right now. And here you will basically see that it auto detected a kind of a change on my branch, and then if I have to see from the history, you'll see that okay, this build is still getting triggered, and it is getting deployed. So if I just kind of reload this page, you'll see that yeah, it has already deployed with demo for GitHub virtual meetup. Now this was like as fast as you can deploy. Likewise, you can deploy it on if I have to like kind of show what happened on GitHub, I'll open this repository. So what I had done over here is basically this repository had a Docker file. Now this Docker file is only helping you to create the Docker image. The building part of it will take care on Cloud Build, or it can happen using actions. Now what kind of triggered the Slack notification? Let us see it on actions. Now you see this, I kind of had as soon as like I created this check-in, or I kind of created this update, it kind of pushed a notification on Slack, and it is kind of showing up on my Slack. So but how exactly did the Slack notification work? Let us open that workflow. If I kind of open this, so what you have to do is basically within your workflows, you just have to call or create a file called as slack notify.yaml, and this file will actually take care of what the Slack notifications will kind of take place. Now just consider that this is an application by itself which is running more like a serverless thing, okay, and it uses the Slack action which has been already built. So which job, so a workflow is basically triggering a sort of a job, and that job is the Slack notification job. It the steps for that is basically what it uses is basically this this Slack notification action, which is called which is created by like rtcamp action slack notify master. And how does it get linked to my GitHub repository? So what you have to do is on Slack, you just have to create a webhook. Now that webhook, you have to set it as a secret on GitHub. So if I open my secret over here, I have created a Slack webhook over here. And if you see this, it's okay. Sorry, I have already added that. So I won't be able to show that URL over here, but it's just a URL that you will get. It's a webhook. You just have to add it over here, and then just make these workflow files into this. That is it, and you will get all the kind of notifications over there. Now if you want to kind of add this in a manner that you also want to schedule this build, then you can have this cron scheduler also over here. So this will not only work on a push, but it will also work on a schedule, which means that any push that you do, of course a Slack notification will go. But if I kind of schedule this and this is what has already been configured, any at every particular schedule, which is like this is like every 15 minutes or at sorry 0015 hours, a build will get triggered, and I will also get a Slack notification. Now, of course, writing that cron piece, I think when you write it in cron, you don't put it in quotes. Here, you need to put it in quotes because cron actually contains asterisks, and that is a special character for YAML. So you need to take care of that. So that's more about like, how you can configure, continuous integration, continuous deployment. And you can now also have like Slack notifications or, as I said, scheduling for your builds. Likewise, there is a whole ecosystem or a marketplace of GitHub actions which you can actually utilize uh, in terms of like what all different integrations or configurations that you want to do. Now, in this case, like, let me also share another possibility that if you haven't worked more on the cloud side of things, what you can do is just have to add this little button if you want to deploy it in a very quick manner. What this will do is it will open Cloud Shell. Now let me click that. Okay, as soon as I click this, yes, it will ask some sort of authentication and configurations over here. Here what will happen is, let us see it in a step-by-step manner, that it is kind of opening a Cloud Shell. It is waiting for the Cloud Shell authorization. Yes, I authorize it, which means that my GitHub repo is now linked to this Cloud Shell and the project that I'm trying to do. Now it has now, if you see this first step, it has cloned the Git repository, and it is asking whether should I go ahead and deploy it. So to deploy it, it needs a GCP project to work with. So I specify a default project for myself, and then it enables Cloud Run API. Now, this is as good as a process that you can think of how even GitHub Actions would work, but then let us see it in a granular fashion. So here, what is happening is it is building the Docker image, okay, and it is building this container image on GCR, which is on the container registry, and it will push it over there. Once it pushes the container registry over there, you will see that it will start serving that or start deploying it on Cloud Run on an almost like an immediate basis. So it is just like milliseconds. So as soon as this container image gets built, it will start pushing it onto the container registry. So while this is happening, let us see if anything changed over here. Yeah, it is still the same. Yeah. So yes, it is still pushing. Now it is like, okay, the container image got pulled, created. Now it is pushing it. Now it is deploying the service to Cloud Run, which means that over here, I did not make any change, but it will still be the same URL. You can check the date time would change over here. So it is like 1410. By the time it gets deployed, it would be another one. Okay, yeah. So this thing got changed. It was like in milliseconds. So yes, so this is also another way to get your deployments done, specifically more into a serverless fashion. And here, what happened over here is, as soon as the deployment happened, all the triggers got activated. Your cloud build. Your cloud build actually started triggering a GitHub image or from the code base, and then push it on the Docker image, created the Docker image and pushes it onto the container registry, and then it deployed it onto Cloud Run. So with that, I actually kind of summarize my talk in terms of like what all things you can actually do with GitHub, Cloud Run, and of course in a serverless manner. The books which I was like kind of, or the references which I was mentioning, if you want to go on an SRE journey, this is something that you can refer to. It is landing.google.com/SRE/books. Some beautiful and amazing references to read out there, a must read if you are into DevOps. So that's it from my side. Thank you so much again to the GitHub team. You all can connect with me on LinkedIn, which is Dharmesh Vaya, and on Twitter at drvaya. And if you want to know more about Agraya, it's agraya.com/cloud. So yeah, that's me.
Great. Thanks a lot for that session, Dharmesh. And I'm sure it's it's useful for all of them to learn more about how you can use GitHub Actions, Cloud Run, and everything else to kind of do serverless deployments. So thanks a lot once again for joining us today.
Thank you so much, Karan. Thanks again for inviting.
Thank you. All right, so that was Dharmesh, who's a Google developer expert for Google Cloud, talking about how you can use GitHub Actions and also the Google Cloud Platform for your serverless deployments using Cloud Run. So our last session for today, we have Dixit, who will be talking about how you can use GitHub for deployment on Azure Web App. So, hi Dixit. Dixit is a customer engineer working at Microsoft Azure, and he'll be talking about how you can use GitHub for deployment on Azure Web Apps.
Hey Karan, thanks for having me. Sure. So let's get started. So just the small round of intro. So I'm the customer engineer in Microsoft, working with the fast track team, and our day-to-day work is basically we interact with startups and help them onboard to Azure and providing the architectural guidance and the best practices. So as Karan has mentioned, that today topics will be the today topic of a discussion will be the GitHub Actions for building Azure web apps. So let's start it. First of all, just the basic the information regarding what is web app, and Karan, I hope you are able to hear me.
Yes, Dixit, we're able to hear you, and we can see your screen
Great.
as well. So please go ahead.
Sure. So, some of the basics about the web app or the app services. It is the highly productive and the completely managed PaaS platform by the Microsoft, and you are able to run the couple of services on the app services, whether it is web apps or web app for containers, API apps, or the mobile apps. So for the web apps, you can host your the web application and directly expose the HTTP endpoint to the customers. For the API apps, whatever APIs that you have, you can directly expose to the outside world and uh, make it accessible to your clients. And as far as the mobile apps is concerned, it is used by the Mac by the backend of the mobile apps, whether it is related to the iOS or the Androids. And also the web app for containers, it is also quite useful for the containerized application, and the scaling needs will be automatically cared by the PaaS platform. And so some of the other things that build on the app services platform is the Azure functions and the logic apps, which can be used for the integration. So that is the, you can say, a 30,000 level feet overview of the app services, which is one of the leading PaaS platform in the Azure world. Moving on to GitHub Actions. So what exactly the GitHub Actions will do, and what we are trying to achieve by deploying the app services with the GitHub Actions. So basically, as in the previous sessions, we have seen that it is also used for the automating tasks in your SDLC life cycles. So basically, the GitHub Actions are the event driven. So we have some event on your repository. You can define some event on your repository, and you define the couple of jobs, and under jobs you can define the couple of actions. Basis on that, your workflow or the YAML file will be defined. So GitHub Actions is you can say just the piece of code that you will define in the YAML file, and that can be triggered basis on some event that you will define. So moving on, just the demo, so that probably I will not spend much of the time using the PPTs. So let's walk through the demo, that how you can deploy the app services using GitHub Actions. So let me switch back to my repository. So you can have this the link. It is github.com Dixit Arora minus MSFT hyphen app service demo. So you can have this the link. It is publicly available, and in this what I have done is I have created a small demo ASP.NET Core app and I have put it in the GitHub repo, and I have created the actions which will when I make some commit to this particular branch, so it will have those the workflow or the steps that we have defined in the YAML file. So before going into that, let's go move on to the YAML file that we have. So this is the YAML file, and let me open the another link. Okay, so this is the YAML file. So first of all, we are defining the name of the YAML, or you can say the name of the workflow. We are saying that deploy ASP.NET Core. On defines that basically the trigger which will initiate this particular workflow. So on the we are stating in this particular workflow that on the push we need to have this workflow initiated. Then we are defining the certain environment variables. In this case, we are defining Azure Web App name, which is called you can call it as a Azure App Service or Azure Web App. So I have called it as a I have defined these environment variables: Azure Web App name, Git action demo, Azure Web App path colon means into the current folder, and the .NET version. So it can be on the lower side, but whatever versions you are running on your machine, you can pick that. And regarding the next thing, we have jobs. So I define the purpose of the jobs. I am saying that it is build and deploy. Then we have the runs on, and we are saying that this will run on the Ubuntu latest. It is also, we can also mention the Windows latest, just to be to differentiate that it also work on the Ubuntu or the Linux system. So we have mentioned the Ubuntu latest. So whatever the latest version of Ubuntu is available, that will be picked up during this particular workflow creation. And the next step is we are defining the steps. So first is that whenever somebody will make a push to this particular branch, first check out the code that we have in this repository. So this is the first steps in the job. The second, I'm naming it as login via Azure CLI. So we are using the action login at the rate v1. So this is the action or GitHub action, we can say, which we are using after checking out the code and login with the Azure credentials. Now, how when we are making a commit to the repository or to the branch, how a GitHub action will make a login with the Azure logins. For that, what we are doing, so I hope everybody is aware that how to make the repository. So I have created the just the repository, and moving on to the settings tab. So from this, under the secrets, we have defined those you can say the Azure credential, or creating the to be prescribed. We have created the service principal and the RBAC role. So what exactly it does? Uh, the app service and the resource group, we have created a service principal which will allow a GitHub action to authenticate with the Azure and provide the necessary permissions to deploy. Now, the service principal that we have make, this is the particular output. So I have purposefully removed the client ID, client secret, subscription ID, and the tenant ID, because these are specific to customers. So don't share with anybody. Just to have the look and feel that what is the secret look like that we have put into the secret tab, which we are calling as the Azure credentials. So when we are creating the service principal, and when we are creating the RBAC, this is the JSON format that we got, and with the values putting in with the client ID, client secret, subscription ID, tenant ID, and all the details that we have put those in the secrets. Coming to the other step, we call it as a name. The setup.NET Co. So it uses the GitHub action .NET at the rate v1. So basically, it uses will install the .NET version, and then we are saying .NET build plus publish. So defining the path where it should be, we are saying to the current folder, and then the last will be the deploy to app services with the Azure Web App name and with the Azure Web App path, which we have defined in the as the environment variables. Now, if I go to the running demo. Okay, so again, same. Just wanted to give you before running it. So we have this particular workflow that has been run 21 hours before. So let's go to the code, update main YAML file. Basically, just for the demo purpose, I'm doing a change directly into this. Let's say I will do some vague name, vague name of the app service or the web app which does not exist in the Azure portal. Now I make a commit changes. Now if I go to the actions, so it's saying that that particular workflow has start. It's in the queue and will start executing probably in a couple of seconds. Now, if I click on update main.yaml and we'll go to the build and deploy. So step by step, it will give us the information that what are all the steps that we have defined in the workflow under the job process, and will give us the detail that whether it is running successfully or not. So it is saying set up a job. So purposefully, this will fail so that we can see that, and in the subsequent run we will run the successful execution. So if you see that setup job, run action, checkout master, login with Azure CLI. So these are the all these we have defined as the steps under the jobs under the YAML file. So it's roughly close to the last step. Okay, now we have seen that there is an error, and rest everything is fine. Now if we see the error, it's saying the resource get action demo 1234 does not exist. Okay, then let's move on again. I will edit this, and now I will give the exact name of the app service or the web app which is existing on the Azure platform. Now we again did the commit, and if we go, then it's again saying that it's queuing up and it is ready for execution. Now it's in progress. Build and deploy. Again, the setup job. Check out the code from the master branch. We are logging with Azure CLI with the service with the Azure secrets or the service principal that we have created. Setting up the .NET Core. Now to the deploy to the app service, which was initially failed in the previous run. Okay, it's successful. Now, if I go to this is the app service application URL, and if I click on this particular URL, so we have the demo application which we have in the GitHub repository. So what we have done as a summary, we have created or probably let me just give me a while. Let me log into the Azure portal as well. Okay, so this is the app service or the web app that we have created. For the code base, we have created a GitHub repository. This is the repository we have created, and this is the app service that we have created in the Azure portal. Now we have the next step is the creating the secrets so that we will be so that the GitHub actions will able to authenticate and will able to deploy to the Azure. For that, we have run certain commands, and it will have those service principals and the RBAC permissions. So those things are getting updated in the secrets. This is the Azure credentials that we have. And after that, this is the complete workflow that we have just defined. So basically, deploying app service, creating a GitHub repository, defining the workflow, basically defining the GitHub action, defining the steps, and whenever some developer or somebody make a commit to a GitHub repository, the workflow will initiate and do the steps that we have defined in the workflow. Yes, that is all from my side, Karan.
Great. All right. Thanks a lot, Dixit. Thanks for joining us today and giving us an overview of how you can use GitHub Actions to deploy on Azure Web Apps.
Thank you, Karan. Thank you so much for having me, and really appreciate and probably will be happy to be part of the future events also.
Thank you, Dixit. Absolutely.
Sure.
All right, so that was Dixit Arora, who's a customer engineer at Microsoft Azure, talking about how you can use GitHub Actions to deploy to Azure Web Apps. So that brings us to the end of the virtual meetup today. That was a really packed and a really exciting sessions that we had, where our speakers spoke about DevOps at GitHub, and also how you can use GitHub for your various different DevOps processes and practices on AWS, Google Cloud, as well as Azure. And we also had the co-founder of the Hasura, which runs the GraphQL engine project, speak about their journey towards open source and how they kind of went about growing their project itself. So thanks a lot for tuning in and for being a part of our virtual meetup today. I know there were many questions which were coming in that we couldn't address due to time restrictions during the session, but please feel free to reach out to the speakers using the individual details that they would have provided in their session. You can also come back and then watch all of these sessions later on YouTube itself, and also do stay tuned to our Twitter handle, twitter.com/GitHub and GitHub India, for our upcoming virtual meetup sessions as well, and various other things that we have for all of you developers out there. So thanks everyone, and this is Karan at GitHub India signing off until next time. So stay safe everyone, and thanks again for tuning in and for watching.